Ready to test your knowledge? In this quiz, you'll explore quality measuring tools. Let's see how well you know the tools that ensure precision and quality in manufacturing. Imagine this. A factory produces thousands of parts every day. But what happens if one small measurement is wrong? A product may fail, machines may stop, and customers may complain. That's why measuring tools are so important in quality control. In today's lesson, you will learn practical English communication used in manufacturing workplaces while talking about common quality measuring tools, inspections, dimensions, and real factory situations. Let's get started.
Good morning, Mai. Are you checking the parts from line B?
Yes, Nam. I am inspecting the metal shafts before packing.
Did you already use the vernier caliper for the diameter?
Yes, but I want to double check because the reading looked a little different.
Let me see the drawing first.
Here it is. The required diameter is 25 millimeters.
The tolerance is plus or minus 0.02 millimeters.
Right. That is why I want to measure carefully.
Good idea. Customers are strict about precision.
I already cleaned the surface before measuring.
That helps avoid inaccurate readings.
Can you hold the part while I use the vernier caliper again?
Sure. Hold it straight.
Okay. The reading is 24.99 millimeters.
That is still inside the tolerance.
Yes, but another part measured 25.03.
Did you measure near the edge or the center?
Near the edge.
Try measuring at the center.
Okay, now it shows 25.01.
That is acceptable.
Sometimes I feel nervous when checking small dimensions.
It becomes easier with experience.
Which tool do you usually use for higher accuracy?
For very small measurements, I use a micrometer.
I know the basic operation, but I still need more practice.
The micrometer is more accurate than the vernier caliper.
Can you show me the correct way again?
First, clean the measuring faces.
Okay.
Then place the part between the spindle and the anvil.
Like this?
Yes. Now turn the ratchet slowly.
I hear the clicking sound.
That means the pressure is correct.
The reading says 24.998 millimeters.
Very good.
The micrometer is sensitive.
Yes. Never tighten it too hard.
Understood.
Did the supervisor ask for a full inspection today?
Yes. We need to inspect every 10th piece.
Then we should record all results clearly.
I prepared the inspection sheet already.
Great. Write the part number first.
Done.
Now write the measure diameter.
Should I include the machine number too?
Yes, because it helps trace production issues.
Machine 4 produced these parts.
Was there any machine adjustment this morning?
The operator changed the cutting tool at 8 a.m.
That could affect the dimensions.
That is why QC requested additional checking.
Makes sense.
Besides the diameter, we also need to check the depth.
Then use the depth gauge.
I have one here.
Make sure the base is flat on the surface.
Okay, now I lower the measuring rod.
What is the reading?
It is 12.48 millimeters.
The specification says 12.5 plus or minus 0.05.
So this part is okay.
Yes.
I noticed some scratches near the hole.
Let me check.
Do you think the scratches are serious?
They are small, but we should report them.
Maybe the fixture is dirty.
Or the cutting chips were not removed completely.
I will inform the machine operator later.
Good.
Yesterday I used a dial indicator for the first time.
Really? How was it?
A little confusing at first.
Many people feel that way.
I was checking runout on rotating parts.
The dial indicator is useful for that.
The needle moved a lot during rotation.
Then the part was probably not centered.
The technician said the chuck alignment was incorrect.
Did they fix it?
Yes, after adjustment the reading became stable.
Good result.
I want to improve my measuring skills because inspection work is important.
Definitely. Accurate measurement reduces customer complaints.
And it also reduces waste.
Exactly.
What tool do you use to check angles?
Use a protractor or an angle gauge.
We rarely use a protractor in my section.
It depends on the product type.
Today I also need to check the length of these brackets.
Use the steel ruler for rough checking first.
Then confirm with the vernier caliper?
Correct.
The drawing says 180 millimeters.
Measure 3 samples from the batch.
First sample is 180.01.
Good.
Second sample is 179.98.
Also acceptable.
Third sample is exactly 180.
Nice. The process looks stable.
Sometimes operators complain that inspection takes too long.
Yes, but quality problems cost more time later.
That is true.
Have you ever used a height gauge?
Only during training.
It is useful for measuring vertical dimensions.
Is it difficult to operate?
Not really. You just need a flat surface plate.
I see.
The measuring tip must contact the part gently.
Otherwise the reading may change.
Correct.
Our factory recently bought digital measuring equipment.
Yes, digital tools save time.
But the battery sometimes becomes weak.
That can cause unstable readings.
Last week one digital micrometer suddenly turned off.
Did you replace the battery?
Yes, after that it worked normally.
Good.
Do we need to calibrate these tools regularly?
Absolutely. Every measuring tool needs calibration.
How often?
Usually every 6 months, depending on company policy.
What happens during calibration?
The tool is checked against a standard reference.
To confirm accuracy?
Exactly.
What if a tool fails calibration?
Then it cannot be used for production inspection.
The quality department will repair or replace it.
Yes.
I noticed some tools have calibration stickers.
The sticker shows the due date.
So we should always check the sticker before using the tool.
Correct.
I also want to learn more about feeler gauges.
They're used to measure small gaps.
Like the clearance between machine parts?
Exactly.
Are feeler gauges difficult to use?
No. You select the correct thickness blade.
Then insert it into the gap?
Yes. The blade should move with slight resistance.
That sounds simple.
It is simple, but you still need practice.
I think measuring work requires patience.
Definitely. Rushing causes mistakes.
Sometimes production pressure is high.
True, especially before shipment deadlines.
But we still need to follow inspection standards.
Quality always comes first.
I agree.
By the way, did you finish the report for yesterday's rejected parts?
Almost. I still need to attach the measurement data.
Include photos if possible.
Good idea.
Customers like clear evidence.
One rejected part exceeded the tolerance by 0.08 millimeters.
That is too much deviation.
The hole diameter was oversized.
Was the drill worn out?
Yes, according to maintenance records.
Then preventive maintenance should be improved.
I will mention that in the report.
Excellent.
Thanks for explaining these measuring tools today.
No problem. We all continue learning.
I feel more confident now.
Great. Accurate inspection helps the whole factory.
And it improves customer satisfaction.
Exactly.
Okay, I will continue checking the remaining parts.
I will help you record the measurements.
Thanks, Nam.